What we want to do here is specify the values of x that are going to make this expression here undefined. Now, this is a fraction. Fractions are undefined when the denominator is 0. So all we have to do is look at this denominator here and see if we can factor it and determine which values will make that factored form 0. So let's set this denominator equal to 0, see what we can find here. So 4x squared plus 4x cubed plus 27x squared minus 7x. What's going to make this 0? Well, let's factor it. We can factor out an x, right? There's an x in each term, so let's take that out. So we'll take out the x, and then what we're left with is 4x squared plus 27x minus 7 equals 0. Let's see what we can do about factoring that trinomial. This will give us now x. Let's bring this x down. Don't forget that x. And let's write our two parentheses anticipating we can do this. So how about, now we can try 2x and 2x for 4x squared. Let's try that, 2x and 2x. And then this 7, only one way to get to 7, a 7 and a 1. And if we put a 7 here and a 1 here, what's that going to do for us? This will give us a 2x and a 14x. Well, 2x and 14x, no way I can get a 27 out of that. So that factored form with the 2 and the 2 is not going to work. So let's cross that one out and try something else. Let's stick with our x. And now, don't forget to equal 0. We want 4x and x. And now, you know, because I'm trying to get a 27 here, I can see, I got to use a 7 and a 1, right? 7 and a 1. And if I put a 7 over here, I'll get 28. That's really close to the 27. So I'm going to try that. I'm going to put the 7 over here and the 1 over here. And I think we have a chance because 28x and 1x, I can get a 27 out of if I get the signs right. This 7 is a negative, so this 1 and 7 have opposite signs, and we're looking for a positive 27. So I'm going to put the positive with the bigger of these two products. Now these two products, I get the outer product, 28x, inner product smaller, only 1x. So I'm going to put the plus sign, that plus sign over here with the 7. That'll give me the plus 28. So the plus will go here, the minus will go here. And now we can read off what's going to give us 0 here. So from that x, we'll get a 0. From the 4x minus 1, we'll get positive 1 over 4. Right? Change the sign of the constant, divide by the coefficient. And from this factor here, we'll get negative 7. I'll separate them by commas, and we'll claim those are the three values that are going to make the expression, the original expression up here, undefined. So what we want to do here is we want to multiply these two rational expressions. Now to do so, what we're going to do is we're going to factor everything in sight and then cancel any common factors. So let's factor everything we can. Let's start by factoring this top left numerator. So here's our two parentheses, anticipating we can do this. So how about x and x? And for this 10 and 1 is not going to work, but 5 and 2 will give us a 7. So how about x plus 5, x plus 2? And in this left denominator here, let's do this one here, this left denominator, we're going to get x and x. Now 40, there's a lot of ways we can get 40. 40 and 1, 20 and 2, 4 and 10, 8 and 5. But the 8 and 5 is going to give us a 3. So I'm going to go with the 8 and the 5. Now the 40 is minus, it's a negative, so the 8 and the 5 have opposite signs. I'm going to put the negative here. I'll get negative 8, and then plus 5 will give us that negative 3. And I can see if I do that, I'll get the x plus 5s to cancel. And at the bottom right, how about if we go with x and 24, since we've got 8s here already, let's go with an 8 and a 3. We can get an 11 out of that. 8 and 3, they're both positive. So we've got everything factored. Now let's look to see if anything's common that we can cancel. Divide out, we'll cancel. So we'll get x plus 5 will go with that x plus 5. How about this x plus 8 going with that x plus 8? This x minus 8 way over here with that x minus 8. I think that's it. And then we're going to see that we have left 1 times x plus 2 times 1 times 1, right? When you draw a cancellation line, you get a 1. So it's 1 times x plus 2 times 1, or just x plus 2 over, and in the denominator, 1 times 1 times 1 times x plus 3. So we're going to get an x plus 3 here. And I'm going to go ahead and do this. I'm going to write down what x's cannot be. So x cannot be, now to do this, just go back one step to that denominator there and pick out all the values of x that are going to make this thing undefined, make these denominators 0. So we're going to get an 8, a negative 5, a negative 8, and a negative 3. So let's write those. We're going to get an 8, we'll get a negative 5, we'll get a negative 8, and we'll get a negative 3. This is a division problem. You can see it right here. We've got a division. We know how to run divisions. We'll invert the divisor and multiply. So take its reciprocal, just invert it, and change the division to a multiplication. So let's do that. So we will have x squared plus 10x plus 16 over x squared plus 7x minus 8 times, now, we're going to invert this one. So we will get x squared minus 7x plus 6 over x squared minus 3x minus 18. Now let's factor. So factoring the top left, we will get an x and an x, and I think an 8 and a 2. For that 16, 8 and a 2, I can get a 10. So how about plus 8 plus 2? And this leftmost denominator, how about x and x? Now 4 and 2 for this 8. 4 and 2 is not going to work because I can't get a 7 out of that. But an 8 and a 1, I can get that 7. So let's go with 8 and 1. And I'm going to put a plus 8 and a minus 1 because that will give us the plus 7x. Times. All right, let's factor this. Top right, we'll get x and x. 3 and 2 for the 6 is not going to work, but a 6 and a 1, well, that'll give us a 7. It's a positive 6, so these are both negatives. That'll give us that negative 7. And then in the bottom right, how about x and x? And I think we should try a 6 and a 3. That'll give us the 18. I can get a 3 out of that. So let's see. I think what we want is a negative 18, so the 6 and the 3 have opposite signs. How about a negative 6 plus 3? That'll give us this negative 3. Now, let's look for and cancel any common factors. So way over here on the left, I see these x plus 8. Those will cancel. What else? Anything? Yeah, this x minus 1 will go with that x minus 1. This x minus 6 with that x minus 6. And we are left with x plus 2 over x plus 3. Do you see them? There's the x plus 2, and way over here is the x plus 3. So let's claim this is our simplified form. So what we're saying here is that this set of computing instructions can be replaced with this much more compact, much more efficient set of instructions. And we can do that as long as we don't divide by 0. So what's going to give us division by zeros? So let's look back here at these denominators. We'll get a negative 8, a 1, a 6, and a negative 3. So let's write those. X cannot equal negative 8, 1, 6, negative 3. And now keep in mind that this numerator here, at one time, it was a denominator, right? We inverted it. So this was the denominator. It became a numerator. So because it was at one time a denominator, we have to exclude zeros from here. So what we're going to get is a 6. Now we've already got the 6 and a 1, and we've already got the 1. But we just have to be careful and check that just to be sure.